interested in it, because I think it's an issue which is very often neglected, or largely neglected, also by our own community. It's going to be presented by Professor Dr. Arif from the Humboldt University, I believe, in Berlin.
Yeah. Thank you very much. It's HTW. So yeah, it's good to be here again. Second time actually. Good to be here. And yeah, let me quickly say a few short words about myself. I used to work in industry quite a while, and I worked for the company ThoughtWorks, which is a global IT consultancy. At this IT consultancy, the idea of data mesh was invented, and I happened to be the role of the head of data and AI in Germany when this was invented. And now for about 6 years I have a professorship at HTW, which is the largest University of Applied Sciences in Berlin. And I actually do continue to work in industry, both as a consultant for ThoughtWorks and also as an independent consultant. So I kind of have a foot in both worlds, right, in academia and in industry still. And I'm actually quite happy that the term data mesh was mentioned before. Simon, for instance, mentioned it in the morning, and also generally the idea of data products. I mean, this is what many of the sessions today were about, right? So therefore I don't have to explain data mesh from the beginning, which really sets the context for this work. But I still want to show this really kind of salesy slide here. I love it for it being so salesy and consultancy. But it really shows kind of where data mesh comes from and what the problem is that data mesh solves. So data mesh is really an approach that comes from large enterprises, from industry. And those large enterprises, they often see themselves at this point here, where they invest more and more into their data work, but at some point they are not getting more impact from investing more in their data work, but they're actually getting less impact from investing more in their data work, right? And this is very frustrating, and as a consultant I've often been in the situation to try to help those companies to get back on this path here, where you can add more to your data work and get more impact, right? And data mesh actually is to a large degree an organizational approach, right? So data mesh allows for this, or facilitates this scaling by reducing bottlenecks and inefficiencies, but moving ownership to where the expertise is. So the idea is that domain experts who really understand what's in the data and what the data means, that they take care of the shape and the quality of the data. And then data engineers who really know how to build efficient and well data infrastructure, they really focus on building domain agnostic self-service tools that enable these domain experts, right? So basically what data mesh is doing, it's facilitating a responsible decentralization, basically by a shift left of responsibility to those domain experts, aided by platform optimization, right? And how we call this in the data mesh community is federated computational governance. And when I moved back to academia, I really made this my research focus, and we published a couple of papers over the last 3 years or so. In fact, one of those papers, that one is from here, from last year, from SummerSOC, and then actually all of the other ones except the one right now here, are at ICWS, so also the services community. So it seems that I found a bit of an academic home in the services community for that topic. And to illustrate what I mean with federated computational governance, I want to take an example from the work that we presented in this paper up here on ICWS last year in Helsinki. And that is a work that where I worked together with Simon and Linus, who we also saw on the co-author list today already. And that example is really on assisting with access requests that involve personal data. Right? So when we build data meshes and build data products in situations or at companies where there is sensitive data, then we often have a situation that we have here a sharing data product, and that data product has an output port and shares their data with a consuming data product, and it should tag this output port here as sharing sensitive, or in this case even PII data. And now how can the data mesh platform that we have beneath here, how can that help, right? The idea is that we still have a central governance, but the central governance is not working like a governance police that is running around and is controlling and enforcing things in terms of governance, but instead they define, for instance, global sensitivity levels, and these sensitivity levels are then provided by the tools provided by that data mesh platform. All right? And then the people building those data products, they can use those global sensitivity levels, and then the platform can assist and can, for instance, see, okay, there's sensitive data coming in, so maybe we'll tag that output port of that consuming data product as PII as well, at least by default, and then the data product builders of this data product, they may override this tagging or something, right? And the work that we did together with Simon and actually implemented in entropy data was working in such a way that we used generative AI to check those access requests and look at global policies and then give assistance in a way to say, well, maybe this access request looks a bit fishy, right? So for instance, in this case here, we have an access request, and then the data owner can approve or reject this access request, and in this case, the governance AI here gives a warning and says, Datenschutzhinweise für Lidl Online Shop, so that is the data protection agreement. The purpose of showing customer data to third parties to find out who's going to pay most for it violates with the classification of personal data, right? So obviously for this demo where I took the screenshot, I typed in a really nasty purpose for that demo, right? Anyway, so this is what worked quite well, also with applying AI here. Now, why does this work rather nice? Well, first of all, the topic of access control is fairly well understood, right? Also, in this case, the data contracts that are at those output ports, they describe the sensitivity of data. And we have organization-wide policies about the handling of sensitive data. And everything runs on the same platform within one company, right? Because this is really where data mesh originates from. And finally, we have an implicit level of trust, right? So, because we're within one company, ideally we all have the same goal, and so it is not so much really about preventing someone from doing something malicious, but it's really more about preventing mistakes, right? But now, what if we want to share data across organizational boundaries? And for this, I actually want to introduce such an interorganizational data sharing scenario, actually a real one, and that is the German mortgage market. So basically, in Germany, when you want to buy a house and you want to get a mortgage, then you, as the consumer who wants to get the mortgage, you talk first to a mortgage advisor, and then this mortgage advisor works together with a company that is a distribution partner, and that distribution partner works with platform providers, so those are other companies, that then match basically the mortgage request from the consumer, that can be the mortgage advisor, with the actual banks, right? And in the end, the mortgage really comes from the bank, but there's actually quite an intricate system behind that, right? And now the interesting thing is that this company and this company, they are often, or specifically in the case that we looked at, they are part of the same consortium, right? They're one group. But legally, they are different companies, so different legal entities. So, of course, in order to work more efficiently in this whole process, they do want to share data with each other as seamless as possible, right? But at the same time, because they are different companies, they do need to make sure they obey all the regulations, etc., right? And so this is really such an interorganizational data sharing scenario that is kind of medium complex, right? It's not totally complex that they are competitors or something, but it still is more complex than the intra-organizational data sharing scenario. Now, this intra-organizational computational governance that I presented before, with checking the access requests, etc., this kind of falls apart when we look at this inter-organizational data sharing scenario. And that is because of a couple of reasons. So, first of all, often we do not have shared infrastructure. Sometimes the different companies might be on the same, at least on the same public cloud provider, so that could help. Also, there is no implicit trust. We cannot be sure that we are all on the same page, right? We have the same goal. And sometimes, well, at least they have the same goal, because they are, as in this case, part of the same group. Also, data contracts are usually about provider promises, right? That's the current state of the industry, is that data contracts state what the provider is promising. And, well, sometimes, at least they specify usage restrictions, but those usage restrictions, they are really not enforceable once we leave the boundaries of one company. And most importantly, well, once data is copied, you basically lose all control of it, right? And that is really the biggest issue here. And there is a problem space, or a community, where we have seen all of those problems before. And that is the digital rights management domain, right? And so what we now thought, or specifically my PhD student Lukas thought is, well, let's look what we can learn from digital rights management for tackling that inter-organizational data sharing problem, right? And we go about this problem in 3 steps, and in fact we've really only implemented 1.5 of those 3 steps. And the first step is really what is the essence of the paper that we present here, and where you can also talk to me at the poster session on Friday. And that is first to map core DRM concepts to the challenges in interorganizational data sharing, right? And you see that we identified here 7 concepts from DRM. That is rights, enforcement, identity, monitoring, watermarking, interoperability, and economics. And then we kind of map this to the to its possible application in this interorganizational data sharing scenario. And then we identify challenges. Well, you see that the right column here is the busiest one, so we found quite a few challenges. But it was still quite interesting because we see that there is, for instance, already an existing language, the Open Digital Rights language, that is really used in industry. But for instance, what we found is that this does not allow any restrictions on a record level, right, among many other restrictions. And yeah, as you see, there are still quite a few other problems here. Now, as the second step, we thought, well, maybe there are some low-hanging fruits, right? And in fact, those low-hanging fruits are all those at leasts that I mentioned on the slide before. So we check whether we can exploit some of those simplifying properties, right? So in this specific scenario, and full disclosure, Lukas, my PhD student, he's working in this company constellation that I presented here. In this constellation, several group members are on the same public cloud provider, AWS to be specific, right? Also, technically they are individual organizations, but they are in one group, so they have a common goal. And we have fairly mature technologies for cross-organizational authentication. And when we use data contracts, at least we can state usage limitations as free text as of now, right? So the solution that is currently there is a very pragmatic one, so not a very scientific one. Basically, group members just give access, give write access to their AWS buckets to data providers from other parts of the group, so other companies in the group, so that this way usage restrictions can be enforced by simply overwriting the data in those buckets, right? And then of course this only works because the data receivers, they basically promise to not copy this somewhere else, but always run new jobs when this is overwritten, right? And in fact, this pragmatic approach within those constraints and those simplifying properties, this works quite well. So this allows for push-based propagation of data deletion mandated by GDPR, for instance, and of course all the involved companies that are interested in implementing this, right? So there's no discussion around this. Also consent updates when users revoke some of their consent, this can be propagated this way. But also when you bought some data and you have a license and that license expired, you can also propagate this expiration, right? All right, and then there is this third step, and that third step is really about treating data like an economic good, right? And interestingly, this is, I think, originally where this data product term comes from, which then has been hijacked by the whole data mesh community and put into a more architectural domain, I would say. So, and this third step is really about translating those approaches from DRM to data mesh, right? And one of the most interesting things that we stumbled upon here is to look into watermarking for structured data. Because in the DRM domain, watermarking is really the tool to be able to follow up where the data is going and to be able to detect and at some point enforce restrictions on the user. And interestingly, this is a very new field. I only found 3 or 2 papers on that topic, and they are from the last 2 years or so. But people are starting to look into how to bake in watermarks into tables. Very interesting approaches are being researched there. Then we want to focus on streaming instead of large data sets being copied, because this way we can enforce more restrictions. We want to make sure that data usage monitoring is really implemented as a standard feature of any data mesh platform. And we want to formally describe usage restrictions, similar how it's done in ODRL, for instance in ODCS. Although I have to admit, because of all the AI things, maybe we don't have to do this anymore, but I think that's a nice discussion for dinner. And another topic that we want to look in here is to use trusted execution environments to really enforce any restrictions, right? And with that, I'm already at the summary. So federated computational governance is primarily designed for intra-organizational challenges, and it really falls apart when sharing data inter-organizationally. However, in many inter-organizational data sharing scenarios, there are some shortcuts that can be pragmatically used, right? But if we really want to treat data as an economic good, we really need to forego some of the traditional approaches like just copying data from one place to another. And the history of DRM provides many approaches and many learnings, also things that didn't work so well with DRM. And we believe that we can learn quite something from there and apply it to this inter-organizational data sharing. Thank you very much.
Thank you very much for the presentation. Is there questions from the audience? No question at all?
I guess I'm between you and
You've been very, very clear about it. And I was wondering myself, I mean, how far are you in this research? I mean, have you been doing also some experimentation in real life settings? Have you built these I guess, products already yourself, or what's the status?
Yeah, honest answer is not really. So we basically what we built are those pragmatic approaches that I presented as the second step. They are really working in those companies involved. But all the things that are in this third step, they are unfortunately not implemented yet. So yeah. That's true.
Okay, there's another question.
Yeah, one of the central parts for such platforms, inter-organizational platforms, it's also security and digital identity, especially between different organizations. How do you tackle that? How do you recognize who is the owner, who can make rules for contracts and who cannot, for example?
So, I mean, this is divided into two questions, right? First is identity, who is someone, and the other one is what is someone allowed to do, exactly. What's their role, right? I think for the pure identification, there are actually quite a few good tools around that are standards in the industry, because we've been working with large microservices systems, etc., that use this. For those roles, in terms of who's allowed to do what, I think this is a much bigger challenge. And I can only give one concept, which is actually the one that I presented here last year, is to basically say, well, I can only share data with you, the other company, if you happen to work on a data mesh platform that provides the same capabilities as mine, right? And then you can basically say, okay, I share this with you. You have to show me that you use a similarly working data mesh platform, and then I can formulate kind of what is a similar role in my context and in their context, so that I can enforce those things. But that's also just a concept at this level.
Okay, thank you very much. And let's thank you again for the presentation.
Thank you.
This wraps it up for today. Tomorrow morning we'll reconvene at 10 o'clock with a beautiful new session. This time being coordinated by my colleague from Sapienza University. There will be two very nice presentations. So I cordially invite you to be there, to show up, and to actively, I guess, participate just like today. So thank you very much for that. And I hope to see you back tomorrow. And by the way, we will be back next year with another session on data, me and Dan.